In the last class, we have seen about list and tuple. Now we are seeing about the set operation. Set is another data structure. I told data structures are the things which will store the data in a specific format. So with respect to the sets, how the data will be stored. In terms of placing this data, so we will place within the flower braces. So or we can use the set built-in function. So this is another built-in function to show you. And what are the properties of a sets? So they won't store duplicates. Till now you have stored in list or a tuple. You might have stored the same values multiple times. It didn't throw any error. So, excuse me. So whereas when you are using this one, so that's not the case. You cannot store duplicates. Also, sets are unordered. What do you mean by this unordered and others? Rather than explaining this, let's touch with a small example. To understand it, let's take the example of a small thing. Is it a set? No, it is a list. I have a list of values. Now let's see how it works with it. Python a so and so. And Python a so and so. Okay. If you see, it is of type list. And how many values are there? 6. 1, 2, 3, 4, 5, 6. And did you observe that there were some duplicates also here? Yes. So what is the way to remove the duplicates from it? So assume that there is no sets. Then without sets, how we can do? Also, this is a method you will need to use whenever you want the order in which the records are present. So what generally we need to do is like, we need to first loop out to each of the port. So for each port in the running ports, so don't you think like we do like this? Each port, if I execute, I get all the ports, right? Now the point is, I will take a new list called as filtered ports or like unique ports, whatever you write. So filtered ports is equal to something I wrote. Now, every time I will check whether I am adding already this into this or not. If it is not there, then I will add. So what I will do, if the each port in filtered port. So how will the port will go to the filtered port until unless you give? It will not go, right? If it is there, you want to continue. Did you understand the uses of continue now? In other case, how we will do? If you see right now, if all values will come. If it is not there, then you want to add filtered ports dot append of each port. If I do like this, then what will happen? Instead of printing, I will add it and I will ask it at the end. Hey, give me the filter ports. If you see right now, did you see what are the filtered ports? 11, 22, and 44. You need to use this much logic to get like the unique values. Now, for the filtered ports, not only this, I will ask, hey, what are the values and what is the length? So if I ask, I get it. If you see, originally it has 6 values, you got 3 values now. Okay, this is good. Now, if the same things, if you want to create using a set, so maybe like I'm using a word called as unique ports. Of course, filtered or unique makes relatively the same sense. Whatever the values you have, you need to take those values. Instead of storing directly, you can use the flower braces. Just change the brace, that's it. Unique ports you got. Now for these unique ports, if I ask, hey, what is the type? What is the length? What is the values? Same what I asked. You can notice that it is of type set. You got the unique values of 3 and this is what you got. Did you see now unique ports also gave a value? If you observe the difference, unique ports also got like 3 values which are unique enough. In the same fashion, if I go for the filtered ports, that is also having the values of these things. Now, but the difference, did you observe? So here you got the values in the same order of you have given, right? Whereas the order may not be the same. Sometimes if you execute in your system, it may be exactly same, but it is unpredictable. Now the point is like, so now you understood in a simple essence what is the usage of sets. Now let's go in detail about sets usage. So first thing you understood is it will store only unique values. You need not do any special operation, just place them, it will store. And two, the values may not be ordered. So they may not be ordered in the way you want. So they will go in their own order. If there is no order, we cannot index. So that is the next thing that I will see. If I go to the sets, as I told, it has like different kinds of properties. What if you want to create like an empty set, first of all? This is a common question everyone will get. Generally, till now, if you want to create an empty list, you can create like this. Or you can pass like list built-in function. If you are creating an empty tuple, you can create empty tuple or braces. But similarly, if you want to create a set, so till now what you learned, okay, set should be stored in flower braces, right? Then what is your thought? Okay, sir. So I will place the same flower braces. Does it work? Let's see. If I use the same empty set, I want to create. If I say clear and Python b so and so. Did you see that first two created list and tuple? That is fine. But did you see the third one didn't create a tuple, but something called as a dict. So for dictionary, it will create. Why, sir? Because in Python, both sets and dictionaries will use the same braces. Then what is the solution, sir? How to create an empty set? You need to use the set built-in function to create it. For others, it is just an option. Either use the built-in function, list, or this brace. But only for sets, we need to use set built-in function if you want to create an empty set. But if you have values, then there is no problem. But now if I create right now, did you see? All four were there. So that is what you need to learn. But when you have a single element, there is no problem. So the problem with single element is when you create a tuple, right? For a tuple, when you create a single element, you need to ensure to place a comma at the end. But for set, that is not a problem. If you have a single element directly, it is a set itself. Now, how do you define a set means? You can define a set in two ways. So just now we learned about the sets. We can represent using these braces, or we can do like this set conversion. Means you have a list of values, you are passing to the set built-in function. That is also a way. So both I am printing and I am doing an assert saying that both are equal. So sets are both equal right now. So the values, did you see that both are coming in the same order, but don't become a, so thing. So sometimes it may be different order. We should not think of it. Maybe let me give one more example. I have some values. Did you see what order I got the values? So if I repeat again, you got it. So different order you are getting. Similarly, next big thing that you need to understand is that sets cannot be indexed or sliced because there is no particular positions. So we cannot index them. So there is nothing like 0th position, first position like that. If I do like indexing of second value, this is the standard error you get. Set object is not subscriptable. You cannot index or slice a set. Okay. So then what is the only way of access? The other way. You can check for a value present or not and do that's it. And on top, what all things that we can do with the sets? If you want to know more about the usage, we have something called as attributes, right? In Python 2, there used to be one more thing called a sets module actually. Means around 2.6 or 2.5. So Python don't have sets initially. They later introduced it like a separate module. So that's why if you go with 2.x, still that module will be there. So that is no more present in Python 3 right now. But just I'm giving you some history. Around 2.6, I guess, it was added. So next, coming to the simple set, if I create, and if I ask dir, dir will give the list of all attributes, right? Python C so and so. So these are all the list of attributes. So as we discussed that we will not deal with the things which have underscores on either side. But still, I want to showcase you briefly that whenever you want to do some kind of operations, so in operation we can do, this is standard across all collections, strings, which are iterables, the same thing. We can use underscore contains or in operation. And also I told you briefly about what is the difference between size of and get size. And similarly, with sets, if you want to do certain operations, so there are few other things called as like this. There is an operation called as underscore end. So if you execute this process, you will understand that the answer is not implemented. I think till now you never encountered this kind of error. So the point is like they reserved this operation. They want to implement in future, but they didn't do. If you do like underscore add of an symbol value, but if you give an iterable, then it will take it. If you give a set and do, it will do it. So we will go about that, what all things which are doing. And as we already know, if you want to get the things which don't have underscores on either side, this is the workaround I created on the other day, right? You remember? There are still a good number of attributes which don't have underscores on either side. I told sets are mutable enough. We can add, remove, delete all the values. Okay, initially for adding the values. In list, you remember, there are three ways of adding the elements in a list. You remember? You can use append or insert or extend. You remember? Append, extend, insert. List dot extend and insert. Sorry. So if you say go for the concept of list dot append or insert, what happens? Whatever the value you give, it will add in the same way, right? So if you give a list, it will add a list like that. If you give an individual element, it will add like that. Similarly, we have set dot add. So it can take both iterables and non-iterables and it will do it. So before initially, let me take these three examples to show you. Initially, I'm printing what is the set. Then I'm adding a 99. Then I'm adding 99 again. Then I'm adding 99 as a tuple. Hope you remember. So single brace with a comma. So now if you notice, you will understand that initially when you gave the values, it will be like this. Then after that, when you have added the, so 99, did you see that 99 came in the starting? Don't think that it will add in the start. It can do anywhere. So you need not worry. In that, again, if you're trying to add, did you see that already if a value is added and if you're trying to add, it will not add. So then on top of it, if you're trying to add again 99, but it's not 99 as an integer, but 99 as a single tuple element. Now, the moment it was added, did you notice that the entire formation was changed? So means it can change in any way. You just need to ignore that order, but it works. But the next important thing that you need to understand in sets is that it will be very strange. Sets are mutable, means we can edit them, but we cannot take editable values or mutable objects. Means in 99 is an integer, which is an immutable. So tuple is an immutable, we can add it, but this is a list. A set cannot take a list within it because list is a mutable object. So this may be a bit confusing for initially, but try to understand. Set will store all the values in a some kind of concept called as hashes. It would want only the things which don't change. If any changeable object comes, it cannot store. So because a list can be editable, right, afterwards. So it will not take that. But set as a whole is editable. We can add, remove elements anytime. Similarly, sir, okay, sir, we cannot add a list to a thing. But can we add a set to it? No, we cannot even add a set to a set. Because set is immutable, so we cannot add a set to a set. This seems strange, but this is interesting. Now the question is, can we add a string to a set? Yes, of course. If you add a string, you will get that value. As I told you, sorry. As I told you, whatever you are adding, it will add to the dimensions. So it doesn't matter where it will store, but it will do like this. Now with add, you can understand that you can give a string, integer, anything. So until unless it is mutable or not, it will check. If it is immutable, it will add it. In the same fashion, you remember, so in lists, we have something called as extend. Extend means like it will take only iterable objects. If you, for a list, if you give a non-iterable object, it will throw an error, right? So like that, for sets also, there is something called as update, which will take only the iterable objects. If you give general values, it will throw an error. So means if I take these examples, you will notice that for this set, I am redefining and I am passing it. So if I am taking a set and I am adding the values, say like 888, then it will throw an error that only iterable objects can be used. Means individual elements you cannot add. But sir, what if I added 88 and 88? So it won't add like a tuple. So as you know, in extend, what happens? It will take a separate object, but add to the same thing. It's like doing a for loop on the same thing and doing an add operation, right? Same like here. So both will be taken, but coming to the same dimension. And subsequently, if you do the same thing again. So this time I'm taking a list of two things. It will take, as it's a triple, it will take, and it will pass each value to it. Now, if you see what will happen, 8 is already there is nothing to add, but 7 is new, so it will add it. Hope you understood now. Now, on top, you are adding these three values. So means like first it will go and check for 8. It is already there, it will not add. Then it will check for 7. Yes, it is already there, it won't add. Now there is one more object called as tuple of two values, 2, 3, and a tuple of 9. So these two tuples will be added. So that's why you would see this one, this end result. You see, it is coming. Good. Now, the next last point. Can we add to the tuple in a better way things? So means like, see. So these things, if you observe, you are trying to add individual elements, right? 8, 7, fine. So unlike the previous one, this individual element is like a list again. So we'll not see the overall object. Overall object, it will do a for loop. And within that, each element it will check. This element is like a list, so it cannot add. Inner elements are like a list, so I cannot add, it says. Similarly, if you take, so this is like an individual element. This is all as a single element, right? So then, so will it add? This is another interesting point I will tell. You may think like, sir, this is an individual element, it is working. This is also an individual element, right? Why cannot I add it? This is one of the interview question, in fact. So let me show you in an interactive mode. So for better understanding. So generally, if I have a set is equal to set of so and so. Now set dot add or update of this one. Observe, this is very interesting. Even so, leave about updating. Think about adding even. Generally, don't you call it as a tuple? It's a tuple, right? So if you ask like assign to a values, so values equal to like this. And if I ask here type of vals, it's a tuple, right? You agree? Now I want to just add it, simple set, or like if you just want to brace within the braces. Oh my God. See, nothing else there. Just I'm placing within the braces. At least it should work, right? But it doesn't work. The reason being all the elements within it. This is all a single element, right? That's a point. Point is like now you need to understand the concept of hashes. There is a built-in function called as hash. Hash is a built-in function that you need to understand. So, in Python, so generally we use the help concept, right? Help of something to get what is the help of it. So this is how we ask for help till now. So I will end. But in IPython, what you do, you write anything and after that give a question mark. Then it will give the help of that. What is the help means? The doc strings, documentation. You give any object, it will give the hash of it. What is this hash means like? So if you give like any integer, it works. See, integer is a immutable. Similarly for hash, if I give like a floating point value, it works. If I give the same thing in a negative fashion, it works. If I give like the string, so you give like a double quotes or like single quotes, it doesn't matter. If you give, it will create a unique number called as a hash. So if I give like a tuple of values, so tuple of values, it works. But if I give like a list, even if it is a single value, then it will throw a value number. Means for mutable objects, you cannot create a hash. That is okay, sir. In this case, what happened? Means I will tell you that. If I give like a hash of say single element, say like I have so 2 as a set, then also it will throw an error, right? Hash of single element I have, if it is so and so. Set also it cannot store. Now the point is it can hash, it can take a tuple of 2, 3 values. It is working, right? The fourth element I will add. Fourth element I am adding like a tuple. Then also works. The fifth element I am trying to add like a list. It doesn't work. Means though tuple is immutable, not every tuples are hashable. You remember this one point. Not all immutable objects are hashable. Sir, why are you telling all the story of hashable and all these things? Because that is the root thing. How Python is storing these sets in a unique way. When you are storing another value, how it knows that it is another value it is present? For every object, it tries to calculate the hash. Okay, for integers, we know that, okay, 9 is a 9. There will not be another 9. But for strings, how you compare? So that's the reason they don't do like every time, character by character to check like whether it is already present or not. For any object when you're storing, they will create like a unique hash. So every time they compare that hash. So that is the reason. So only hashable object they will store. Hope I gave the big picture of what's happening. So these are the two ways in which you can add the values. Then, sir, how to remove the elements? For removing elements in sets, there are 3 ways. Set.pop, set.remove, set.discard. So now let me explain this. So what is this set.pop, set.so and so? If I give like some set, you got some values. Say if I do like a set is equal to some values I give. So 1, 2, 3, 4, 5, 6 something I am giving. No matter how many times I give, it will store only how many times it want to. You see? If I give duplicate force also, it got only one time. And you know the concept of pop. Pop by default in list what does? It will remove the last element, or if you give an index, it will remove it. Here we cannot give an index and we don't know which is the last element. So if you just do, it can remove anything in random. So it is doing right now in the starting, right? But don't imagine like that. It may do tomorrow in a different way or in your system in a different way. So it will remove something in random. So pop every time removes some value in random. We cannot assure what will happen. But sir, what if you want to remove a specific element? So for that, we need to go for remove. So remove is an operation which will help us to remove a specific element. Say within this simple set, if I ask, I have two elements. If I want to explicitly remove only 4, I can give 4, I can remove it. So subsequently, if I ask, it won't be there. So again, if you are trying to remove 45, it will remove it. Subsequently, if you ask, it will not be anything. But the problem with this remove is that if you remove something and subsequently you try, or if you're trying to remove an element which is not present, then it will throw an error. So how to solve this problem means sometimes if something is not there, you want to break the code. Or sometimes if something is not there as per your logic, you want to stay silent. So for that, there is another attribute called as discard. Discard will remove an element if present. If it is not present, it will not do anything. It will just stay calm. So Q is not there, but it will not do anything. You try to remove 100 times also, it will not do anything. Means if it is there, it will remove. If not, it will stay calm. And the last 2 points that you want to learn is about in sets, if you want to create a copy. Hope you remember this concept of copy problem, right? So for that, if you want to create a copy, you can do like this, dot copy. And again, the copy problem will not be that prevalent in sets because sets won't store mutable objects, right? No problem at all. But still, if you want to create a copy, you can use copy attribute. It will create another copy for the same thing. If you see, yes. So if you create like a copy, it will create a new object with a different address location. Whereas clear is like a same operation, like in a list, to remove all the values, but object will be there. So like that, if you want, you can rely on it. So based on these inputs, now try a couple of assignments. Try adding a string to both set.add and set.update and observe the difference. So you need to create a small set, add tomato to both the things and see how different both were there. So fine. Um, so next thing, in terms of set operations, what kind of set operations we can do? With sets, we can do operations mainly into the first thing. Till now, the basic attributes you have seen. So preliminary attributes you will see. Let's say I have two sets called as rainbow. So rainbow, it will have all kinds of colors, WebGR. And I have traffic lights like yellow, green, bright, white. Generally, white won't be there, just for some understanding I give. So I have two things right now. So clear and Python, D so and so. So two sets are there. Now, when you have two sets, with these sets, we can do some operations. So what are those operations means? Traffic lights is subset. Is subset means it's easy to understand. All values within the traffic light will present in the rainbow. That's what I'm trying to say. Similarly, if I do the things in the other side, in the reverse. So rainbow is like a superset, telling the same thing in a different direction. What if I remove this white color? Now, if I ask, is it like a subset and superset? Yes, because so in traffic light, what are the colors are there? All those colors are in rainbow, right? Here, order doesn't matter whether they are present or not. Similarly, if I go for like one more thing, if I say a brand new thing called as alphabets, it has nothing to do with colors. With respect to this, if I ask, hey, is it a subset or superset? No. Similarly, now the concept of disjoint comes to picture. There is another thing called as disjoint sets. Generally, when you are working with the sets, there is some concept called a disjoint. When there is nothing common between two sets, it's called a disjoint. So in this case, are traffic lights and rainbow disjoint? No, because there is something common, right? So, and what is that intersection? So if you want to check whether both are having anything common or not, D is disjoint. If there is anything common and if you want the common values, that is intersection. And if you do the same thing with alphabets right now, you can notice that difference. Alphabets is nothing is common, right? Is it disjoint means yes. So when you do for a disjoint set, if you ask what is intersection, it will be empty. Fine. So the next point that you need to understand is that till now you used the plus operator for both sets, lists, everything, right? Sorry, list, tuple, everything, even tuple also used. But for sets, plus operation is not supported. So we cannot do like a plus operation. But the beauty is like in a list, we cannot do minus operation. Have you ever tried a minus operation on two sets and two lists? If I take like list one, so minus list two, if I say two, remove it, it will throw an error. We cannot do a minus operation, but sets will do that. So how sets will do is like if I give 1, 2 minus 2, if I do. So it's a common sense. It will remove the elements which are common. Sir, if there is nothing common, say if I ask to remove 3, as there is nothing common, it will not remove. But if there is anything common, it will remove the common elements only from the first one. So if I say like, if I say 2, 3 is there, if it is removing, I will not get 3. Only from the first set, what are the common elements between first and second will be removed and you get the remaining. So for that, I wrote like different kinds of things there just to help you understand. So that is the set operations. From the first element, remove the elements which are common between these two. So you can do a minus operation or set dot difference. There is another attribute called as difference. In the same fashion, if you have two sets and if you want to get the combination, so that is called as a union. Yeah, this is called as a union. Union means all the values will be combined. So to understand this concept in a better way, there is something called as set Venn diagram. Hope you remember this set Venn diagrams, what you have learned in your schooling, graduation, multiple times, right? Venn diagrams. So these Venn diagrams will be a clear way for you to understand for any operation. If you have two values, what is the union, intersection, and all these things? So this is like a intersection B and all. So if I give a better example, I think this is good. You see now? So you have three values. There is nothing common. Whereas here, 3 and 4 are common. When you do intersection, you get the common values. And here, it is like a subset. All the elements of it are present in this one, right? And now this F is like a superset. E is like a subset. Like that. So there will be common, not common, union. Union means combination of all, like that. These are all the Venn diagrams for you to better understand. Then, sir, what is this concept of symmetric difference? This is very interesting. Symmetric difference means like A union B minus A intersection B. To understand, so if you don't know anything, Venn diagram, same thing I do. Symmetric difference, if I ask, you will understand. If I go for some kind of images, you will see that. So did you understand? Union means combine all of them minus remove the intersection part. That is called a symmetric difference. So this is symmetric difference. So if I ask the values, I get the answer. That is symmetric difference. So the next thing is that similarly, after doing the set operations, we have the concept of mutability. Sir, why I'm telling mutability again? There is some interesting point here. So till now we know that sets are mutable. That is fine. So, but there is one more thing called as a frozen set. So till now we know what is a set. Yeah. Till now we know ordinary set. You create it, you do like a addition, but you cannot go with like a substitution, but you can add the values, remove the values and all these things. So, but there is something called as a frozen set. If you compare this with an ordinary set use the set built-in function or the braces. For frozen set, you need to use another built-in function called as frozen set. If you define that, it will create the frozen set. Sir, what is the difference between this and that? For ordinary set and a frozen set, the main difference is that you cannot add the values. When I'm trying to add the values to a frozen set, it will throw an error. Did you see I created a frozen set and I'm trying to add the values, it will throw an attribute error. Means it won't even have an attribute. It's same like, tuple for a list. So if you see the DAR of an ordinary set and a frozen set, you will notice it. For an ordinary set, you have a lot of operations, right? Add, clear, remove, all these things. But for a frozen set, only set operations are there. No operation like add, remove, delete, nothing. So that is what you need to understand. So whenever you are working on a frozen set, it have all the features of an ordinary set, except that we cannot change it. So means within sets, there are two types of sets, like ordinary sets and frozen sets. So we can do all kinds of operations. So if you try for doing an ordinary frozen set, you can create a frozen set, you can add the values. So, sorry, you cannot add the values subsequently. You can do all operations like union, intersection, all of that. But once you create a frozen set, subsequently you cannot add or you cannot delete that. So next, I told the concept of hashables. What is the story behind the hashables and others? Why we need to understand. Just to make a list of you, I'm just listing all those hashable examples. So I'm telling that quickly that ordinary things we can hash. But like if you have a list of sets or something, we cannot hash. So if you have deep within the values also, we cannot hash. I'm showing with different data types to show you. So next, coming to the case of a sets, the frequently asked questions. If I say, this is very interesting. In most of the interview questions, you will find this very useful. So whenever you go for sets, if I give like a one true int of 1.2, now tell me what will be the answer? In fact, int of 1.2 means you get int 1 only, right? True is also having a value of 1. 1 is also 1. Then when you execute, what will be the answer? So this is interesting. The answer would be true. So 1 only. Sir, why 1 came as a thing? Why not the others came? Means there is nothing specific. I did a lot of research, but what finally understood is that whichever comes first, it will take it. Because whenever it is creating the value, further it will create a hash and store that. So subsequently for everything, it tries to create the same hash. As everything has the same hash, whichever first comes, it will store. In these three cases, the same thing is there, but the order is different. So in the initial case, first 1 came, next in this true came, in this int of 1.2 came.